The @MCP tool decorator looks simple to use until you apply it to an instance method, and suddenly your LLM can't figure out what to do with that self parameter. We'll examine why directly decorating instance methods fails, and how FastMCP's decorator system expects standalone functions or properly bound methods instead. The upcoming example reveals the exact pitfall to avoid when registering class-based tools. From FastMCP, import FastMCP. MCP equals FastMCP. Class my class. @MCP, tool hash this won't work correctly. Def add, self x y. Return x plus y. This demonstrates the incorrect approach to registering instance methods with FastMCP decorators. The core issue is that decorators like @MCP tool capture the unbound method at class definition time before any instance exists to bind the self parameter. This creates a mismatch where the LLM sees self as a required parameter it cannot satisfy, breaking the intended tool registration. The problem occurs because Python's method binding happens at instance creation, but decorator application happens during class definition. When @MCP tool is applied directly to an instance method, it receives the unbound function rather than a properly bound method, exposing implementation details, self, to the external system. FastMCP expects standalone functions or properly bound methods, not unbound instance methods with implicit parameters. This matters because it highlights a common pitfall when combining object-oriented patterns with decorator-based frameworks. The solution requires explicit binding. First, create an instance, then register the bound method, MCP, tool, obj, method. This ensures clean parameter lists for external callers while maintaining proper method binding semantics. The trade-off is more explicit registration code, but the result is reliable integration between your class methods and the FastMCP system. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. However, the example demonstrates the incorrect approach to tool registration, directly decorating instance methods with @MCP. Tool fails because FastMCP cannot handle unbound methods during class definition. To properly register instance methods, you must first create an instance, then decorate the bound method. The official docs recommend using standalone functions instead, as @MCP tool is designed for functions, not class methods. MCP equals FastMCP. This instantiates the FastMCP controller, but the real issue appears in the next lines. You cannot directly decorate instance methods with @MCP tool. The decorator expects standalone functions, not unbound methods. This pattern silently fails because self breaks FastMCP's tool registration. To fix this, either use standalone functions or bind the method to an instance first. Class my class. This defines a class containing an instance method incorrectly decorated with @MCP tool. FastMCP's decorator cannot properly register instance methods at class definition time because they require a self parameter, which conflicts with FastMCP's expected function signature. The official solution requires either using standalone functions or binding the method to an instance before decoration. @MCP, tool hash this won't work correctly. Def add, self x y. This demonstrates the incorrect approach to registering instance methods as FastMCP tools. The @MCP tool decorator fails here because it cannot properly handle the self parameter of instance methods. FastMCP tools must be standalone functions or properly bound methods. To fix this, you would first create an instance, then decorate the bound method or restructure as a standalone function. Return x plus y. This demonstrates the incorrect way to register instance methods as FastMCP tools. The @MCP tool decorator fails here because it can't properly handle the implicit self parameter that Python adds to instance methods, preventing correct AI tool registration. For instance methods to work, you must first create an instance and then decorate the bound method, or use standalone functions instead. FastMCP instance method registration. The @MCP tool decorator cannot properly bind instance methods during class definition because it captures the unbound method, exposing self as a required parameter that the LLM cannot satisfy. Directly decorating instance methods with @MCP tool fails silently, but creates unusable tools that will error when called. To properly register instance methods, first create an instance, then register the bound method using MCP tool instance method.
The method that belongs to everything belongs to nothing.